This last video is going to be pretty short and sweet, and there's only one video to watch, so that's always a good thing too. Continuation in chapter 13, section 3, which is our radian measure section. In this last little bit here, we are going to learn a formula for the length of an arc. And remember that an arc is the length of a chunk of our circle. So it's the segment, the outer length of a segment of our circle. So this would be an arc. I can find the measure of that length by this little formula. S equals R times theta. And in this equation, S tells us the arc length. R is the radius of our circle. And theta is our angle in radians. So for example, if I had this chunk of my circle, this is the arc length I'm trying to find. As long as I know my radius and I know what this angle is, I can find it. Okay. So here's my angle, here's my radius, here's my arc length. All right, let's use this now. Let's say this is example 1A here. I'll do a B example here too. A satellite travels the circumference of Earth in a day. The height of the satellite is 36,000 kilometers. The radius of Earth is 6,400 kilometers. About how far does the satellite travel in 8 hours? Okay, let's start off by drawing a picture. It's kind of my motto here lately. If you can't tell, draw a diagram. It makes life a lot easier. So here is the Earth. And the radius of the Earth is 6,400 kilometers. I'm going to start off by drawing that in. Now I have the satellite that travels the circumference of Earth in a day. So a whole day travels all the way around the Earth. And this satellite is 3,600 kilometers. Sorry, 36,000 kilometers. So all together, here's our, I don't know, we'll pretend that's a satellite. So if this is the orbit of the satellite, the whole radius here is 3,600 plus 6,400. And that ends up being 42,400 kilometers. Well, if we look at our equation, S equals R times theta. S is the arc length. Well, if we're trying to figure out how far that satellite travels in 8 hours, we're looking, we're really looking for an arc length here. We're trying to find S. R we know now. Theta we have to figure out. That's where our time comes in. Now it says that the satellite travels the whole circumference of Earth in a day. So in one day, we go all the way around the circle. In one day, we go 2 pi radians. Well, if we're traveling for 8 hours is a third of a day. So the satellite's going to travel a third of the circle. And a third of 2 pi, think of that as 2 pi over 1, is 2 pi over 3 radians. Okay, now the last thing that we could do, or the last thing we need to do, is take our radius times our angle. Our arc length is our radius, which is 42,400, times our angle, 2 pi over 3 radians. And since this is an application problem, we want to figure out approximately what that is. Type this in your calculator, and you should get, it's about 88,802.35 kilometers. So in 8 hours, yes sir, a third of our circle is probably something like this. In 8 hours, our satellite is traveling 88,802.35 kilometers.